Alright, so we're going to quickly go over the quiz so you see how to do this stuff. I would, if I were you, make corrections, write some stuff on here because this is now part of your notes. You get to use your notes on your quiz, so hint, hint, wink, wink, okay? I was kind of pleased with how it started. It got progressively worse as we went along, but I was happy with this. I'm going to do as much as I can without a calculator. When it gets to the point where you could use a calculator, I would trust y'all to do that. I think only you got an extra point.
Yeah, I'm a
Right?
one.
We're using for not using your notes. Everybody else, I think y'all just caved in and used your calculator. Alright, so let's look at number one. Oh, I thought it was too easy.
I mixed them up.
Yeah, by the way, if you get a negative answer for area or volume,
not
for
right.
this kind of area or volume, then yeah, you probably didn't do something right.
I don't know.
When they say area under the curve, then you can have negative area, the stuff that's below the x-axis, but if they ever say the area between or the area enclosed by, that is always positive area, so you should have known something was wrong.
I tried.
You're A forever.
Well, not really.
Y equals x squared minus 3 and y equals 1. Crude sketch. You have x, there's y equals 1 cutting across that way, and then x squared minus 3 would look something like this. Okay, so this was the point you were looking for. I think you found these points, which was great for the roots, but there was still a little bit more area to actually calculate. These do meet at -2 and +2. I think for the most part was pretty straightforward. So it's just gonna be top function from -2 to 2 minus bottom function. Top function in this case was the line, which was 1. Bottom function was the parabola, which was x squared minus 3. This is not the way I did it, but it's a decently good setup. First thing I would have done is to clean up the inside. That is going to be 4 minus x squared. The other thing I did, just to make it a little bit easier on the math, I noticed the symmetry involved, so instead of going from -2 to 2, I only went from 0 to 2, and then doubled it. You will get the same answer regardless of which of these you plug in the calculator or do by hand, okay? And I am gonna go ahead and finish this one just so you can see what a non-calculator problem would be. Antiderivative is going to be 4x, that's going to be 1/3 x cubed from 0 to 2. This is why I truly appreciate using zeros, because polynomials and zeros get along so well, especially on this class. Alright, we have, stick in 2, we get 8 minus 8/3. Stick in 0, we get 0. That is 24/3 minus 8/3 is 16/3. 16/3 times 2 is 32/3. Or decimal equivalent would be 10.6 repeating if y'all went that route. Okay, which I think all of you did. Or 667 if you're going to use 3 decimal places. Yeah, I know. Turned it sideways for some reason.
I don't know why. I was just like sideways.
Okay.
I don't know why it still didn't work if I did it that way.
Yeah.
Still should be right.
You'd think. The problem with turning it sideways, okay, yes, if you feel like making that kind of heartache for yourself, if you turned it sideways and went like this, you'd go from -3
3 to 1.
to 1. Your top function would be the positive root of this, and the bottom function would be the negative root of that. Or just do the top one doubled.
Which is what I did.
Okay, did you get the right answer?
No, that's what I'm saying. Like, it's set up like it's supposed to be.
Yeah, it was.
I turned it sideways and it
I don't
still
know
should have worked,
about
but it didn't. So I don't understand.
Probably had something to do with the antiderivative. If the setup was fine and the integral was fine, then it more than. Did you get half of that? Did you get 5.3?
I got 6.928.
I have no idea where that came from. None at all. Did you do y plus 3 or y minus 3?
Plus.
Okay.
All I had to do was take off the negative and I would have got it.
Or write me a note that says, this is backwards, oopsie, something like that.
Oopsie.
I did that in 3.
All right, number 2, the curve, oh, all right,
Should've thought of that.
I love this one.
Okay,
Do you know what you did?
nope, but
Still can't recreate the answer,
I can't recreate that answer, let me check this, if this is.
but you can get all kinds of other different answers.
Oh, yeah, I put, it went from negative 3 to 0, not negative 3 to 1, so I got that.
Oh, look at that again then, I'll be able to give you,
Because that's the.
because your setup is, I should give you more credit than that, yeah. Okay, so that, the x-axis, and vertical lines, x equals 2 and negative 2. All right, crude sketch. It's gonna look something like this. And then cut it off there and there, so this is the area we're looking for. Again, I went with the symmetry approach to do from 0 to 2 and double it instead of going from negative 2 to 2, but you get the same answer either way. So, my area is going to be, for me, 2 times 0 to 2 of that. Now, we'll say this, all of you got this one right, this one was pi. Some of y'all recognize it as pi, some of y'all just got the decimal at 3.142 and were like, there's my answer. Some of y'all looked at it and went, I recognize that number, okay, that is pi.
Oh, I should've
I don't like
recognized.
assuming.
Oh, well.
Assuming.
Yeah,
I looked down, I was like, is this 5? You know, I typed down, I was like, that is 5.
that is pi, yeah, that's pi.
Assuming that.
Okay, so because you all got it right, part of me is like, fine, I know how to do it. So I asked the question, do you want to see it without a calculator, or are you perfectly fine with the answer of pi?
I'm good.
I'm guessing you just,
Here's a
turn
bonus
it into
question, can you tell what this is gonna be? What we're gonna have to use to take the antiderivative?
You're gonna use a U sub to get it to,
What form will we wanna get it in? Do we wanna get it
isn't
in?
that tangent?
That is the
Arc
arctangent,
tangent.
right, so if we're gonna use U sub,
You take the U sub
I'd
4.
factor a 4 out and then turn that into 1 over
And then
U.
the 4x.
That'll cancel. So if you want to do this one without a calculator, think arctangent,
And then the arctangent of,
okay?
I'm guessing that from 2 to 0.
Well, you could either use the arctangent and switch it back to x's, or what I did was switch it to u values, and the u values are 0 and 1, so both those numbers were great inside the arctangent. Okay, but the right answer for this one was roughly, well, not roughly, it was pi. I think most of y'all just put the decimal 3.14, y'all rounded it to 142.
Yeah.
Edward said pi, Edward recognized that as pi. Anybody
I
else
said
put pi
pi.
on there? You put pi on yours too? Yeah. All right, number 3. Oh, number 3.
I like it.
I did it right.
Okay, you have the curve y equals x cubed minus 2x squared minus 3x, and the x-axis. All right, so we want every bit of area that is trapped between those two. Sketch, this is what we're looking at. There's a little chunk right here, and then a bigger chunk right there. This is -1, that is 0, and that is 3. You can find that from your calculator, or you can set this equal to 0 and factor it and get those 3 numbers. All right, now, some of you went ahead and from here just said antiderivative from -1 to 3 of y. I'm not gonna type it out, but all that crap, okay? All that stuff right there, blah, 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 blah. That's gonna give you a negative answer. Here's why, because there's more negative area than there is positive area. So what can I do to this to give me the right answer? The value. So you can slap this on here, and if that's all I did with my calculator, then boom, we are done.
If you want to do the work, well,
You don't have to do the work. If you wanted to do this one without a calculator,
you would just minus it
Oh, I
by,
could've done that.
you would just do the top.
you would do from -1 to 0, get that answer.
And then minus it.
Do 0 to 3, get that answer. You know this is gonna be negative, so make it positive, all right? Both of these will give you the same answer of 71/6 or 11 and some change. 6.833333 repeating, something
It's
like that.
11.83.
11, sorry, yeah, 11.83 repeating. Cool.
Nice.
Anybody need to see that, or y'all feel good with the setup? Good, alright. Then we get to the volume limits. Holy crap,
Oh, dang.
this is painful though. Actually, I think y'all did fine with 4.
I messed up one part.
Overall,
I got
you
4.
did fine with
I just
4.
put
Alright.
square on the outside. I'll put it on the inside.
I don't remember how I got it.
See, what would have happened then for you, I think your answer is half what it should be, because if you stick it on the outside, it
Yeah.
squares the 2 as well, and then it doubles
Down
whatever
it
you
goes
got.
together too.
Alright, find the volume of the solid whose base is the region enclosed by this. And whose cross sections perpendicular to the x-axis are squares. Alright. I think some of y'all graphed this, tried to.
Yeah.
If you're going to graph it, you have to graph it in 2 pieces, but it's gonna be an ellipse.
Mm-hmm.
That is 2 left and right and 1 up and down, okay? And one thing that the Green Sea kids messed up on, they did a great job of solving for y, but they only used the top half of it and not the whole thing, so they just assumed the graph looked like that. So their answers were like 1/4 of what they should have been when they did that. Okay, let's talk area. Area of a square is side squared. Sure, did that right? Yeah, square, okay. So the side length is gonna be the distance from there to there. There, my square is popping up out of the board. That length is going to be twice whatever one of the roots is. If you solve this, you're gonna get y equals plus or minus square root of 4 minus x squared over 4. Okay? That's the top and the bottom half. All we really need to do is take either the top minus the bottom, or just take the top and double it, it's the same thing. So a side is going to be that doubled. I could write 4 minus x squared over 4. So side squared. Now watch what happens if you clean it up. That's gonna square and get a 4. This square root gets knocked off, so you're gonna have a 4 on top and a 4 on bottom. Cancels. That square root and square knock out, so all you have is 4 minus x squared, if you clean it up, okay?
That's easy.
And then if we do the volume, we're just gonna do the interval. We need to go either from -2 to 2 or from 0 to 2 and double it. I'll do that. Of 4 minus x squared. And that will direct your attention to question number 1. It was the exact same problem.
Yeah.
So if you
I
recognize
realized that
you
whenever I
can-
got the answer.
Okay. So that one is still gonna be 32/3, it hasn't changed.
I was
Well, that's
wondering.
cool, actually.
Ta-da!
Damn.
I'll just say C number 1. Okay. Tried to give you a little gift there. If y'all had done it right, that the answer was waiting for you. Assuming 1 was right, and assuming you cleaned it up correctly. There's a lot of assumptions there.
Assuming it.
All right, find the volume number 5. Oh, more cross sections.
You.
Okay. We got x cubed plus 1. We've got y equals 2 in the y-axis.
I was very scared for this one because it's very little volume.
Yeah, it's a teeny tiny little zone. X cubed plus 1 looks like that. Y equals 2 looks like that, y-axis. So this was the base of our zone. And
It was.
y-axis cuts were equilateral triangles, which was annoying, but there you go.
Most of the Y.
Unless you have the formula for it. Okay, so here's what I need to do is figure out what the area of an equilateral, it's not equilateral, which it is, okay? We know that this distance, which is the base, is going to be, not that, it's going to be, you have to solve for x. You get the cube root of y minus 1, you solve for x there. So my base is going to be that. Cube root of y minus 1. Okay, to set up my equilateral triangle, we're going to cut it into a 30, 60, 90. That makes this piece right here half of that. And that makes this times the root of 3. You can do the Pythagorean theorem if you want to, but man, does it get messy.
What did you say? I mean,
Square root of 3 over 2
of that.
cube root y minus 1. So our area of a triangle, 1/2 base times height, is going to be I'm going to run out of room here. Yeah, a little bit. Area in terms of y, 1/2 base times height. Okay, if we put all the numbers together, you will get square root of 3 over 4, and this is going to be y minus 1 to the thirds. That's about as clean as you can get it. Then our volume is going to be the interval from, now we're doing y values here. Go ahead and pull that root of 3 over 4 outside. The y values are going to go from 1 to 2. And then we'll have a y minus 1 to the 2/3 on the inside. Okay? I'll go ahead and give you the answer, but if you're doing this one by hand, that's u sub, and I'll let u be y minus 1. And when you let u be y minus 1, you don't get any crap tagging along. There's no extra number thrown in because the derivative is just dy. So it ends up being u to the 2/3. And then you take the antiderivative and go from there. Right answer, if you go through all that rigmarole, is 3 root of 3 over 20, which is somewhere in the neighborhood of like 2.5, 0.25 or 2.6 or something like that.
0.26. Oh, okay.
Cool, all right.
So 2.269, then like another.
259 something that pushes the 9 up, which pushes the 5 up, yeah. Okay, how do you feel about the first 5 before I clear the slates? Here's what I feel. Your calculus is good. Y'all can take antiderivatives. Y'all messed up on the areas and figuring out the shapes of the objects, and it was all that crap. If I start you here, that's a joke. Y'all really do have antiderivatives cold. It's going from here to that picture that some of us are still sketchy on, or remembering that the area of a triangle is.
It's time for the same question.
Do it.
Same question.
This is funny. 6, as I was grading, I'm like, okay. I think you got 6 right.
Yeah.
And then a lot of other people got the answer for 6 right, but the setup was wrong. And I went through and did the work. I think you, I don't remember. Did you get 6 right? Yeah, you were fine. And your setup was fine, yeah. And I was wondering, okay, so maybe they just screwed it up and they copied the answers, but then I worked out the way y'all did it, and it actually turns out to be the same answer. So y'all got lucky on this one that the answer, if this had been a multiple choice question, y'all would have gotten lucky that year, because it was good.
No, it was not.
Yeah, it was not the same. All right, so we have the volume of the solid formed by rotating this region right here. And our region is the square root of x plus 1, which is going to look something like that. Y equals 3, which will look something like this. And the y-axis, so this is our zone right here, which you all got, good. And we're going to rotate it around the line y equals 5. Y'all rotated around the x-axis. So you did, y'all rotated around the line y equals 5. That was good. So here's the one we're going around. My outside radius will be that. My inside radius
Dang,
will
that's
be.
really lucky.
will be that. Yes, yes.
That's actually pretty cool, actually.
You know, that would make a fantastic free response question if they said, okay, part A, find the area, or find the volume of this is rotated around the x-axis. Cool, easy.
Fun.
And then they said, okay, there's a line that if you spin it around it, you get the same volume. What's that line?
Oh,
That would be a hot question. I've seen one like that before. That's
How would you solve what you just said?
well, you would, since you know what the volume is, you would set up an equation and say, let's go around the line like y equals k. And then you do an outside radius of k minus this and k minus that, do the antiderivative, and then set it equal to whatever the volume was you got when you did that, and then solve for k. Gives me an idea. All right, so we got 0.
no ideas.
And they will meet at 4. If you set these two equal to each other, that will be at 4. So my volume is going to be disk method, okay? Disk method, so we're going to be pi r squared, 0 to 4. Disk means we're doing I'm sorry, not disk.
It's washer.
Washer, which is 2 disks. Outside disk is going to be here, inside disk, that is not right. There we go. All right, is there.
Okay, there you
Finally, okay. Outside, 5 minus that
go. That.
squared, pi r squared, minus pi r squared.
Which comes 4.
And I do want to point out that it makes sense because the inside radius is always 2, the distance between 3 and 5, so the formula makes sense like that. You're boring out a cylinder from the middle of this. Okay, go through the math, yada, yada, yada. This one, I would honestly, if I were doing it by hand, that's 4.
That's 4.
I would go ahead and combine this and get 4 minus the root of x and then square that, makes it easier. If you do that, if you're curious, this is what it will look like. If you clean it up, where am I? There it is. You get 12 minus 8 root of x plus x. Okay, and that's if you make that a 4, square all this crap out and do that. Take an antiderivative, yada, 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 you get 40 pi over 3, which is somewhere in the 41, almost 42 range, somewhere along in there.
41.22.
There you go. Any more, do you need to see anything else or any discussion on that? I don't want y'all to get verklempt, you should ask questions if you need to. All right, 7. Oh my word, y'all hated 7, and it made me happy.
I just didn't have time.
I just rolled Y.
There is.
I started and then I'm like, okay, now I just have to do it, and then I just ran out of time.
Okay. 7. The volume of the solid form by rotating the region enclosed. By the way, first thing I would have done is graph that to see what I was looking at, which is I think what a lot of y'all did. It's a neat one. Okay. This part of the graph does this as an asymptote right here, and then at 1 it bounces and does like that. Okay. And the line x equals e is out here. Okay, somewhere out there,
X.
beyond the pale.
Oh. Wait, no, I did that.
So here is the area in question, and we're spinning this around the y-axis. Well, crappy
Whoopsie.
crap.
That's what I was trying to do.
Is that y equals e?
That's Y equals E. Which is why it looks so awkward.
Yeah, crazy talk. Okay.
I think I might have done that too.
2 good ways to do this one, by the way. You have,
Reverse it.
if you're gonna switch everything to y, because you go around the y-axis, that is washer.
Or
If you're gonna leave it in x, it would be shell. And this is one of those cases like it would show up on the test. They say you don't need shell, but it makes this problem a lot easier if you use shell. If you go with washer, you got a lot more work. It's not difficult, but it's a lot more work. So let's do the washer first and then compare that to the shell. Okay, what was our equation? Natural log squared
Mhm.
of x. Okay. first, if we're gonna convert this to y values, this is 0, I need to know what this is. That's pretty easy. If you plug in e to this, figure out what the y value is. Natural log of e is 1, and 1 squared is 1. So this peaks out at 1. Figure not drawing scale. Okay. So my interval will be from 0 to 1, if you do it that way. Okay. I also need to look at it like this, as far as what is top and what is bottom. Pi, again, washer. Top function. Top function is this line e, so e squared, pi r squared, top. Minus bottom. Okay, let's do some scratch work. If we were to solve this for x,
You would.
first thing I would do is take a root
And
and then exponentiate, so get e to the root of y. Alright,
delicious.
so e to the root of y squared dy. That is the washer setup. Pi outside radius, inside radius.
See, I was trying to like split. I came to the point where I was trying to split the split
region,
function
yeah.
region in half, and I'm like, this isn't working out well.
What else was I gonna say? You can get, you can do that by hand. That's just a number. A lot of people look at that and think it's gonna be 1/3 e cubed. E squared is just a number, so that would be e squared y, is all that is, okay?
So
This, because the radical's in the exponent, a little hard to do.
Calculator.
Yeah, calculator. Or you can set this up with shell. Both, by the way, will need the calculator. Shell, 2 pi. The thing with shell is it lets you stay in x's. We don't have to transform this to a y value. My x's go from 1 to e. My radius, because I'm going around this, my radius is just gonna be whatever x value I stop at. And my height is going to be the function value itself. And there's the shell setup. Okay, no conversions, no nothing like that. Both of these will give you the exact same answer, 10.036.
Okay, 2.
036.
It's all, you just left the 2 in front of it, now it's shell. And then you don't split.
Yeah, it's a lot more different than that, but slapping a 2 and not squaring is not, yeah.
Same thing.
Again, this is what I mean, and I hate that they say you don't need shell, because it really, a one-day lesson, and it makes sense, it's not that hard for them to throw into the content, it is pretty easy. And it does make a couple of, I would say maybe 1 or 2 on the AP test tops, it makes it easier, but everything on the AP you could do with washer, could. The choice is yours though. They do accept shell answers. If you write it in shell form, they're perfectly fine with that. Okay?
Because the teacher's like, you teach it.
It is mathematically sound. I could teach you BC calculus, and if you use it on that, then it was perfectly fine, but you won't need it anywhere. Okie dokie.
You try to use it.
Well, I take that back. With BC, you could do this by hand, but we don't need to know that. Okay. All right, ta-da! Any questions on 1 through 7 of the old quiz? Feel good?
Yes.
Yes, awesome. All right, solo time. I hope you took the notes on that, because you could use that. It's in your notebook now. You could use it to reference on the quiz today if you wanted. That's not the folder. Here it is. All right, relax. Good luck with it. I'll get one of these to grade for you. Oh, same deal applies, any ones you do by hand, I'll give you 1 bonus point, any ones you use a calculator on, you still get full credit for
Alright,
your
let's see which one I
bonus
can do
point.
that.
Might I suggest that you go ahead and get the answer with the calculator to have that weight off your shoulders, and then if you got time, go back and see if you can scrape out an extra point or two by doing it by hand. Oh, can you turn us off? We're done. Good luck with the quiz.
You would pencil.
Yeah.
I like it, man.
Is that all? Or
It's the silver button on the side.
on this side? Or
Right there.
right here? Right here?
I don't think
Did I click it?
works well.
Try to push it in.
It's-
It's on the back.